This video will be a quick video showing you what the ion charges and the valence electron count are for the 8 main group element columns, and then some ion charges from some of the transition metals as well. So when we talk about the 8 main group element columns, the ones highlighted in pink here are the ones I'm talking about. So it's your alkali, your alkaline, your inner transition metals, your nonmetals, your metalloids, your halogens, and your noble gases. Okay, why are they called the main group elements? They're the elements that we encounter most frequently. They're the ones that are most abundant in nature. They're also the ones that tend to follow a more consistent pattern. So we can learn something about them by learning their patterns, where our transition metals down here, these guys and these guys, they tend to act more just a certain way because they're transition metals, kind of as a group. So we talk about those guys kind of as a group and a whole. Now, we talked about the modern atom. We talked about how as we add more and more electrons, they end up being in further and further, basically, orbits or orbitals around the nucleus. So if we imagine our nucleus being in the center and our electrons being somewhere out here in the cloud, our first 2 electrons go on the lowest energy level, and then from there out, the next energy level that's available has 8 electrons. Now there is some subdividing in this level. There are 2 different sublevels on that level, which we're not going to get into too much. And then as of the 3rd level out here, we still have 8 electrons. Okay, and then as of the 4th level, which is the levels do correspond to the rows. As the 4th level, you can see that we have these 10 extra electrons to worry about. So some people say the 4th level actually has 18. So 2, 8, 8, 18. But since we're only going to deal with main group elements, each of our basically shells are going to be considered to have 8 electrons. Okay. So when it comes to valence electrons are the electrons that are in that outer shell. So how many electrons are in the outer shell? And so how that works pattern-wise, and again, this periodic table was created based on patterns, is that our first column has 1 electron in the valence energy level. Okay, so for hydrogen, right, only has 1 electron that's going to be on the inner shell. But for lithium, which has 3 electrons, 2 went in on the inner shell, and then that 3rd one had to go on the next energy level out. And that's how it's going to work for all of them. So for sodium, this 2nd energy level is totally full, and now its first electron is going to go on that 3rd energy level. So all of the elements in that first column have just 1 electron in the outermost shell. Second column then now has 2 electrons, right? Because it has room for 2 electrons to fit on that shell. Now helium could technically be right here to be part of the pattern of just having 2 electrons, but it's over here because it's a noble gas. So hydrogen and helium are weird on the table because they kind of have multiple places they could be. Okay. Now moving over here to our 3rd main group element, they now have 3 electrons in that kind of main group block that they're filling in for their valence. And then we just keep going out the count because essentially every column is another electron being added. Okay. So this 4th column is 4, and then the 5th column has 5, and then 6, and then 7, and then 8. So if I ask you how many valence electrons does something like sulfur have, where sulfur is in the row where there are 6. So the location in the columns tell you what the valence electrons are for each of these guys. Second thing we want to talk about are ions. Now remember, ions are either created by the loss of electrons or by the gain of electrons. And here's how life works. As I already said, one thing that's driving life is they want 8 electrons in the outermost energy level. One way to go about gaining 8 electrons is either to lose or gain electrons in order to get there. So if elements lose electrons, the loss of electrons is going to end up resulting in a positive charge because you'll have a surplus of protons. If you gain electrons, you're going to end up with a negative charge because electrons are negative. So this first column with only 1 electron in its outer shell, if it was to get down to 8 electrons, essentially if it lost that electron, the next shell would be full of all 8, and so it would be happy. So those tend to lose electrons to become positive, and if they just lose 1, they're nice and happy and stable. Now, second column has 2 electrons, so if it loses both of those, it's going to go down to H, just like for the alkali metals. Skipping the middle, now for the third column, I have those 3 excess electrons to lose, so I'm going to lose all 3 of them, become positive 3. Fourth column, I now kind of get to this breaking point where I could lose 4 or gain 4 in order to get to 8. And really energetically, both are hard. So I would say this column 4 or 14, really they don't tend to gain and lose electrons to become into their octets. They're going to do something else. Now, once I get to this column that has 5 electrons, I could lose all 5, but it would be much easier to try to go out and find 3 rather than lose 5. So they're going to go find 3 electrons to become a negative 3, and then the pattern continues. They're going to find 2, they're going to find 1, and the noble gases are so stable and unreactive because they don't need any. So they're nice and happy. So those are the common ion charges. So if I ask you like, hey, what's a common ion charge on calcium? Well, it's +2 because calcium's in that column. Now, one thing that's a little messy over here on the place where we have 6, this is called our P block sometimes. Over here on our P block, we have this staircase, and metals and nonmetals behave differently. So metals tend to lose electrons to become positive, and nonmetals tend to gain electrons to become negative. So when we label this column right here as +3, that's kind of true. Boron tends to make a +3, aluminum tends to make a +3, but once you get down to these bottom ones, they're a little more complicated. They can make multiple different ions to be stable. Okay, so sometimes they make a +3, and sometimes they make a +1, and both of those are possible. Now, on that fourth column where there's no charge, that's really no charge for these top 2. Down here, tin will do a +2 or a +4, as will lead. So they do end up making some charges down here. Now, once I get to the -3, the negative charge is really just for the nonmetals. So nonmetals tend to make a negative. Underneath then, these guys are going to make positives. So they can actually make a +3 or a +5, depending on the situation. And then as we keep going, it's these top ones that are going to make -2s, the top ones that are going to make -1s, and the last column, those are all 0s. So your inner transition metals, these guys right here, right, they don't necessarily follow the pattern of the charges that we see, okay? Now, the normal transition metals, they make all sorts of crazy charges, and we'll learn some of them. They make a variety, but I will tell you that zinc always makes a +2, and silver always makes a +1, and those come up a lot. Okay? So there's your overview on some of the charges. Those are things you're just gonna have to memorize all of that information and be able to apply it. So go do the quiz and have a nice night.